yesterday we looked at given zeros, write the polynomial. What if they only gave you 1 0? And it was a complex 0. So this one says the complex 0, 1 minus 2i, is a 0 of this function. Find the remaining zeros and then write as a linear factorization. So normally when we have a 0, we do synthetic division and we divide it out, right? Yeah. Can we do that with a complex number?
I mean, yeah.
Let's try it. This is going to be great with my smart board that's...
Wait. Before we do anything, can we just, it'd be 1 plus 2i, and you put those together, and then after you solve everything, then you do the division?
That's the other way to do this problem. So I don't know. So there's two options here. There's a synthetic division way and a long division way. All right? So Savannah says, what if we just do synthetic division? That's nice. We divide it out, but then we're still going to have to divide out its conjugate too. We're also down here somewhere going to have to divide out 1 plus 2i. Sean is suggesting, well, if 1 minus 2i is a 0, I also know that 1 plus 2i...
Half erasing.
Oh my gosh.
Just got to work with it. This is my life right now. So we could do like we just did on number 9 or 6 or whatever one we just did, that if these are the zeros, we're not just multiplying those, we have to put the x minus, right? So the other option here is we could say, I'm just going to, here it's just going to be easier. Actually,
you know that if you call Jared, he's going to come down here and it's going to work.
I know. So I could do x minus 1 plus 2i times x minus 1 minus 2i. Is that the exact problem we just did on homework?
Yeah, it is.
I think it is. That we FOIL it out?
Yeah.
So this is still going to be a good amount of work, right? So we could FOIL this out, not FOIL, distribute it out, and I think that it equals...
X squared plus 2 is 5.
Plus 5, I think.
Okay.
Someone can check the
Do it, I believe in you.
Nope, I'm just going to type it. I'm going to have to do this.
Fancy X.
Plus 2x plus 5. Is that what it was?
I got x squared minus 2x.
Oh, look, you know what I can do? It's right up here. Minus 2x plus 5. You are right.
Sean's just like...
So the other option, and this is where you get to decide, which one do you want to do? The other option, no, that's just not 5, that's annoying. Is 2 zeros already multiplied out that we could divide into this. But can we do synthetic division if we're dividing by a quadratic? No. So we either could do this and do long division,
Yes.
or we could do synthetic division twice. I always do synthetic division. No one's ever suggested this so early on in the example that we talk about it before I even do the synthetic division. But the long division works as long as you multiply this out correctly as well. So I'm going to do both just so you can see it, but then it's your choice. If it was just like 5i and not 1 minus 2i, probably I think synthetic division is just as easy too. But a lot of people missed on the test, a lot of people missed their long division question because they messed up their subtraction. So if you're one of those people that are like, I pretty much mess up long division every time, then maybe you should stick with synthetic division, even if it's a little bit more work. Because lots of people messed up that long division question. But I'll do it. So let's go this way. God.
We can power through.
Like we could just use the chalkboard. We could use the chalkboard if you want.
Chalkboard.
That's all the way over there, and then
What is that? 17x to the third?
It's what's up here.
Oh.
You could turn your desk, kids. It's not that hard.
hard.
I messed up already, didn't I? Why'd I mess up?
What'd you say?
I messed up.
Messed up.
What do you have to remember when... I didn't fill my 0 in, right?
Well, you don't have to do that. You just have to not be stupid.
Wow.
Did you just
No, you have to.
really calm?
No, I know what he's
No, I
saying.
didn't call her. No.
No, I'm with you.
Sean, no.
Because you just have to know that there's nothing there
Yeah.
and not freak out when your stuff doesn't line up. But people freak out. So, oh look, I just did it again.
Yeah, I don't know.
One of my tricks of how I type math now.
I was like, what's that? That's so fancy.
Oh my goodness.
Nice.
That's, wow.
I'm just gonna do this.
I am so impressed with how straight that line is. Yeah.
All right, so if I'm doing long division, I say x squared times what gives me 4x to the fourth.
4x squared.
4x squared.
I'm gonna just attempt this again.
Alright, here we go.
And then it really isn't that bad because when you multiply by this, like it's gonna fill in 3 of these already. And so it's not as awful as it looks because it's so long there. You just gotta make sure you multiply correctly. And again, my advice is just multiply and then go through and subtract. Like don't try to do it all at once. So I'm just gonna multiply this and I'm gonna get 4x to the fourth. And then 4x squared times negative 2x is negative 8x to the third. And then 4x squared times 5 is plus 20x squared. And then I'm going to subtract. And again, I always go through and subtract everything. So I go through and I subtract, which means that's going to change the plus sign, and I subtract that. Because it just helps me keep my sign straight. And that's what people mess up on in long division. So this cancels out, and if I'm subtracting a negative 8x, that becomes positive 8x to the third, and 17 minus 20 is negative 3x squared. Bring down my next number, and I just repeat it. So then what do I multiply x squared by to get 8x cubed? And then I just keep going here. 8x cubed minus 16x squared plus 40x. And I'm going to go through and subtract. And I've never done it this way, and I feel like Sean's converting me right now to this is the better way. So negative 3 plus 16 is 13x squared. 14 minus 40, negative 26x. Is that true? And then my last one to bring down is plus 65. So here's where this is discouraging. They told us this is a 0, and we know this is a 0. So if we don't get a remainder of 0 here, we've done something wrong. And that's what's discouraging about these problems, because you do all this math, then you get down and you get a remainder, and you're like, crap, I messed up somewhere. And then you don't want to go back and redo it because you're mad. I'm with you. And then you come to me and you're like, where did I mess up? And I don't know, because it's hard to follow long division sometimes. But then I just do it and try to compare. But hopefully we did our math right here. So I'm going to put a plus 13 here. True?
Mm-hmm.
So I think this is going to work.
Yes.
13x squared minus 26x, and 13 times 5 is 65. So when I subtract that, oh look, I didn't change colors. I do get a remainder of 0, which is what should happen because they told me it's a 0. I don't even think I'm going to show you this instead of division. Do you want me to do this?
Yeah,
instead
Because
of
long
division?
division. Because long division is amazing.
The synthetic division, the first one's really awful because you have to FOIL, like you get eyes in the bottom row and then you have to FOIL with your eyes, and then it gets really gross. The second one's not so bad, but the first one really is a lot of work, and I think I've been converted to the long division way. So, in your book, I will tell you, they do the synthetic division way, which is why that's what I've always taught. Example 5, actually, aren't used to carrying the book around, let alone reading it. But example 5 on page 231 does this exact problem. So maybe you could open your book right now to page 231.
If I had it. See, yesterday you're like, we need our books, and then we didn't use our books.
Well, if we have time to work on homework, that's why you use your book.
I Thanks to the extra credit online.
So,
Touche.
Does not work as much as the book homework, though.
Okay.
Like, just keep that in mind.
you sound like, I'll be alright.
But I'll show you for those that don't have your book. When you do the synthetic division, you just get like i's in the bottom row. Like you just multiply the same way you always do synthetic division. But you have to FOIL. Like you have to take like 5 minus 16i times 1 minus 2i to get the next spot. So there's a lot of foiling out there.
No.
But then when you go to the second row of synthetic division, for that one, like it works out really nice and you don't get that stuff. But it is a lot of math, but I've always felt like it's easier to division, but
No.
That looks.
I think
That
Sean is
long
winner.
division looks better.
Sean is winner. So, but if you're someone that hates long division and you want to work through this, or you want me to work through it with you, like that's the exact same problem that we did in the synthetic division. The book makes it seem so nice because they don't show all the work to the side and how to work that out. But we're not done with this problem because it says find the remaining zeros. So we know that this is a 0, but now what we know we have left is this. So I have to solve that still.
Oh, yeah.
So I have to do the quadratic formula.
Or including the square.
Or including the square.
Formula.
Nobody does that but me.
We can do stuff to the thing that you want to do because we did what I wanted to do.
No, it's okay.
So, no.
Everybody knows.
No. We're doing what we want. At least the quadratic formula.
So, -8 plus or minus the square root of 64 minus 4 times 4 times 13 all over 2 times 4.
That's a lot of math.
Negative 208
Calculated. Do you say negative 208?
is the negative 4 times 13.
So when you subtract 64 or 64 minus that, you get negative 144. So you get -8 plus or minus the square root of negative 144.
So it's like 12i.
That's 144.
Wait, what do you subtract there?
I did 64 minus the 208 or whatever he said.
It's 12i.
I always do what's under the radical all at once on my calculator. If it's big numbers, like I just typed in my calculator 64 minus 4 times 4 times 13.
No.
And I got -1, that's a 44, 144. my words just not working.
It's dumb.
So it's 12i.
So it's just 12i. And then I'm going to cross out the 8s and just say it's 12i, right?
No.
No, no.
No.
The negative.
Yes.
You are incorrect.
3i over.
Please.
Negative 1.
No, over 2.
I can divide all of that by 4.
Yeah.
So -2 plus or minus 3i all over 2. Or if you want, remember, like you can make each 1 over 2. Like you could say that's -1 plus or minus 3/2 I. Like that's what your book says a lot. I just always leave it big.
Isn't
Answer
that
big.
how the homework wants it?
The online homework, I think, likes it like that.
No.
And then our other answers
Two.
were 1 plus or minus 2i. Those were our other 2 answers that we had up there, which means this problem was a 4th degree polynomial, but all 4 answers are imaginary, which means that like it never crosses the x-axis. It means if you try to do PRZs, you wouldn't get any of them to work because they're all imaginary.
Oh, so we actually didn't do this problem.
The other thing that it asks us to do here is to write it as the linear factorization. So that's kind of the new part that we talked about yesterday. The linear factorization, you take your zeros and you write them as factors. And again, if the plus or minus confuses you, you could write them all out as separate zeros. Like we have 1 plus 2i, we have 1 minus 2i, we have -2 plus 3i over 2, and we have -2 minus 3i over 2. And then you're just going to do the x minus all of those, right? So to write it as a factor, we're just going to do x minus, but you have to change every sign in there.
Ugh.
And just like we talked about yesterday, if there's a fraction here, you can just like multiply the x by that denominator, and then you get rid of the fraction, and that's how your book's going to do it. So I think I could write this as f of x equals x minus 1 minus 2i, x minus 1 plus 2i, and then I'm going to multiply the x by 2. So I'm going to say 2x, so move that up, and then plus 2 minus 3i, and again, I'm just changing the sign of both of those, and 2x plus 2 plus 3i. And if you multiply all those back out, you would get the original problem. But there's no expectation that you would do that. Because you would just get back where you started and you just did all that work for nothing.
That's like the weird thing about math. Like, you get the answer, but then you realize if you actually do the answer, then you get
Then
the
you
problem
get back
started.
where you
You're
started.
like, what was the point?
To go from that to this. Whew, that's exciting, right?
So,
Not the word I would use.
it's not the word I hate. It's there.
All right, that was the worst of the day, though, right? That's good.
Yeah, we've done.
Oh, look, I left you a blank page to do your work. I forgot to tell you.
Oh,
But it's still left.
Just don't draw us.
Sorry about that. That was supposed to be for when you needed more room to write.
How considerate of
I
you.
know. Sorry.
sorry.
I forgot until you turned the page.
I was like, oh, what's this? Oh.
Savannah just wrote a sad face. Okay, so we can write our zeros. We can write them as linear factors. Oh!
Okay.
No, I just ran my back into the corner of the shelf.
This sounds like
Oh, that really hurt.
on the recording.
Take a minute. Just take a minute.
So we can also talk about writing our factors as a product of linear factors and irreducible quadratic factors. What do you think that means? Irreducible.
You can't
You can't reduce it.
They can reduce.
They
can
they can't reduce without being ugly, which means if it's not factorable, you don't have to do the quadratic formula or complete the square if the directions say leave them as irreducible. So this means if not factorable,
Yeah.
Nice.
leave alone.
If not, I will leave alone.
Which is my favorite kind of directions because then I don't have to get ugly, gross answers. I get nice, easy, pretty answers.
What's we call lovely and
Gross. How about gross answers? Like the one we just did, those were gross answers. Pretty sure my back might be bleeding right now.
You were like,
It hurts so bad. Okay.
How bad is it? You're like,
I'm fine. It wasn't as bad as when I fell before.
I just, like, that's gonna be on the recording.
It is.
It's gonna just side.
Ah!
you hear it, thunk.
I would have cried. So good for you.
They're gonna think that, like, you got stabbed.
It was the banana.
I've scraped my leg on this before. There's this metal thing here. I've scraped my leg through my pants, and then I go home and I have this cut on my leg.
Those are like the worst ones. One time,
Like
when I was
going
in
to
the
war.
locker, I like stood up and a locker door was open, and it like scratched all the way down my back. And then like everybody was like, "What's wrong?" Like I was like, "I hit myself on a lot."
All right, so
The worst thing.
again, directions are really, really important. It might say find all the zeros. It might say write them as a product of linear factors. Or now it might say write as a product of linear and irreducible quadratic factors. And so make sure you pay attention on what to do. But on all of them, you have to start with list PRZs, plug them in, find one that works, right? We just keep doing the same thing over and over and over again.
It's funny how math builds on itself.
What?
I don't know why you said that so angrily.
Recording my hearing.
So my PRZs, again, it's amazing how nice the ones I picked to do in the notes, right? Factors of 2, plus or minus 1, plus or minus 2, over factors of a leading coefficient, which is just 1. So I'm just going to find one that works. If I plug 1 in there, it's not going to work. If I plug negative 1 in there, if I plug 2 in there, don't even know why I'm going to pretend that it's going to write over here. But.
Oh, it's close. Hey,
It's still
yeah,
close.
you're good.
It tried to spare you.
Two. What? Yeah.
So, so that's x to the third. So now this is x squared plus x plus 1. So yesterday I said find all the zeros. This says only find the linear and irreducible quadratic factors, which means, is this factorable?
No.
Which means you don't have to solve it. You get to leave it as a quadratic factor. So that is a factor. And since 2 is a 0, how can I write that as a factor? I just write 2. X minus 2. And then I probably should say equals y or equals f of x.
Yay, backwards math.
Doesn't that look so much better?
Yeah.
I like
Oh my
A
gosh.
paragraph work, yes.
That's not that much work.
No, I'm saying like rather than.
So again, direction's really, really important. You gotta know what that means when it says that. Okay, is the next one just the same thing? Okay,
Yeah.
you do this.
Longer thing.
You start it. Find your PRDs, plug them in, find one that works.
But we only have 10 minutes.
Go.
But we
That's
only
one,
have.
isn't it?
Yeah. Thanks.
No, no, that's not an example, it's just a summary. PRDs, go. Pick up the pace.
Don't yell at me.
I'm sorry, certain person.
Oh, there's so many.
Yeah, my whole page doesn't want me to write on it. It just doesn't register.
You're so funny.
You're so. You're
When do
silly.
I think it's gonna work?
I can only go to 4 because it stopped writing.
6 and 12 were good.
All the way up to 2. I said all the way up to 2.
Okay. Let's skip the 1 and 2.
Okay. Not sure.
Wait, you got 1 and 2. Like this one, like this.
So this work is no, I haven't tried negative 2 yet.
We all trying to get.
Plus or minus one, like a working. Negative one is one.
I'm doing 3.
Wait, 8.
2 to the 4.
That?
Change.
Well, heck, I'm done then.
Yeah.
1 minus 2 plus
1 plus 2
3 works.
1 plus 2
plus 1 minus
8
plus 8.
minus 1. Okay, yeah. These are both words.
Sean, what are you doing?
3 works too. Just saying.
Stop ruining it.
Sorry.
You're taking all the fun out of it, Justin.
No, he's
This is
making
fun.
it easier.
This is fun to you? I
Yes.
would hate to see what you do at home.
Yes.
I watched that movie. That's actually pretty good. What movie? Gladiator.
One of these days I want to be a gladiator.
Gladiator.
All right, so -1 works. You divide it out, you get what's left. Again, when it's x to the third to start with, you're always left with a quadratic after this. But this one's x to the fourth, so when you divide one out, you're left with x to the third. That's really the worst that I'll give you, right? I don't ever give you like an x to the fifth. That would be terrible.
Probably wasn't that bad.
I'd skip that problem and not.
So here's where you have options, okay? One option is you can keep guessing, which Justin's already guessed for us and found that 3 works also. The other option is that sometimes, not always, but sometimes what's left you can do factor by grouping, and then you don't have to do any more guessing.
Wow.
So I always look with what's left and I say, hey, could I do factor by grouping on that and get that to factor? And I think that it works. And it saves you from doing the more simplified division. That doesn't always work, but it does work sometimes. All right?
Can we just practice this synthetically?
What's
No.
factor by group?
I'll do both, all right? But like, if I group these two together, do you see how you can take an x squared out of that? And you're left with x minus 3?
Oh, yeah.
And you can do.
Oh, yeah.
And if I take out a 4 on this one, I'm left with x minus 3.
Oh, yeah,
And then
why
it's
did I
x
do
squared
that?
plus 4. And then
So I get,
Plus 2, x minus 2, x minus
Wait, could we have been doing this earlier?
yes, if it's factor.
You.
I don't think we've had any that worked that way yet.
No.
They don't always work out this way. Sometimes they're not factor by grouping-able.
factor by group.
Sometimes it works out, sometimes it doesn't. This one works out that way.
23 worked. It's
Don't forget that you have to use, like, don't forget the one you found already. If negative 1 was a 0, the factor would be x plus 1. So, what about x squared plus 4? Is that factorable?
Yeah. No.
That would be 2i as an answer, right?
We don't like that.
Right? If it was x squared minus 4, we could factor it, but x squared plus 4, we can't factor it.
Why?
Yeah, you did.
Yeah, you did.
Justin, we could also, at this point, if you didn't want to do factor by grouping, or if it wasn't factor by groupingable, what's a new word I made up? Pretend that you can read those.
Are you writing in a new language?
Yes, whatever brothers show up, that's funny.
So notice that when you do your division, you would now be left with x squared plus 4, which is exactly what we got over there when we did factor by grouping. And again, it's not factorable,
Leave that as it is.
and then you put your other factors with it. So I always look for factor by grouping because it's better than guessing more points if you don't know which one works already. That's why I yelled at Justin and said, don't ruin it. He ruined my factor by grouping story, but.
It's okay. It's not my fault that we work as a group.
So,
Do we work as a team on the
is it
test?
just x squared plus 4?
No, you have to write all the factors. So like you have to write all the ones you found already. So 3 worked, and negative 1 worked. So you should make sure you write all the ones that worked as factors too. So again, not really anything new today, except for now we could write them as irreducible quadratic factors, and we can do the long division stuff. And then this is not a problem, it's just a thought. In your book, in a little green box, it says, every polynomial function of odd degree with real coefficients has to have at least one real 0.
Why?
Why? That's what I'm asking. So I'm not even degree, like we just did a 4th degree one that had 4 imaginary answers. So even degree, that's not true. But if it's odd degree, it has to have at least one real 0, or at least one x-intercept, Sean.
Because each imaginary one has to have another imaginary one, but the opposite.
So yesterday we talked about conjugate pairs, and conjugate pairs have to come in pairs. So if it's a 3rd degree function, you could have 2 imaginary zeros, but then you'd have that one left over, right? And for any odd number, you could have pairs of imaginary numbers, but you'd have one left over. Definitely true. You could also prove this by talking about in behavior. What do you know about odd degree functions in behavior as compared to even degree functions? Yeah. Odd degree in behavior, the arrows go up and down, so like it's going to cross at some point. Even degrees, they'll both go up or both go down, so they might not ever touch. So that's another way that you can think or prove that this is true. That was just like
We aren't going to go back to proof.
in summary.
It's like next one's
No.
Not as much as geometry. We'll do with some.
Wait, what?
So notice your homework today is only 5 problems. One of them is like the long division problem that we did. So try it. Probably I'm not going to do it on the board for you tomorrow, but I'll help you if you get stuck on it and check your work. But I want you to do it because I only gave you one of them like that. And then there's some irreducible and quadratic factor stuff.